Today we're going to discuss the topic of the basics of cross-compilation as well as the basics of cmake. In this project, we're going to use the MQTT code base from GitHub. So cross-compilation is when you do your build on one CPU platform. In my case here, I will do my build on an x86 64 desktop, and that build is going to produce a binary. It could be a library or an executable of a different platform. So in my other terminal here, I'm logged into a ARM64 system. Specifically, it's a Jetson Nano board. It's also the same CPU, ARM CPU 64 in Raspberry Pi. So let's switch over to the main terminal here in my desktop. Perhaps the primary reason why you're going to do it like this is the target system most often has a very limited resources, so you're not going to do your build there. It's going to take time. It has less RAM and it might not have a graphics IDE. So this is the reason why cross compilation in a host base with more powerful tooling is comes very handy. So first let us clone the MQTT code base. This code base is in pure C and it uses cmake as its build system. Now let me pull in my cheat sheet here. Give me a sec. So this is where there is another cmake, a main cmake of the code base, and the MQTT is built as part of a chain of build flow from a main cmake. So there is a main cmake with its own cmake list, and then MQTT has its own cmake list. It's a chain of build flow. So I'm gonna copy this. Okay, and I'm gonna first I'm gonna remove this, and I'm gonna copy this. So this is how I build it. So I'm gonna just use this as a template. Okay. Yep, you can do the basics of creating a build directory and launching cmake, but um, I just want to use this cheat sheet so that I can have all of the sharp defines in my build. So we already clone the code, and then secondly we're gonna switch to a tag. Okay. Because right now we are in the master branch, which is going to be constantly changing over time, and it might break your build. So to have a reproducible build, the best practice is you're gonna check out to a fixed stable branch in the tag of v1.38. And now we are in that tag. So the next step here, I created a build. So let me create a build now folder. And then you will see the use of capital minus B and capital minus S. In older cmake, these cmake arguments may not be available and you will encounter errors. So you need to understand how to overcome those errors because older cmake that doesn't have these command arguments could still work if you know what the error means. So since we switch directory to the build now, so we will not be needing the minus b argument. This is only good if you're referring to a folder from a distance, but we now switching to the build, so we will not be using this. And since we'll be using dot dot, so we will not be using minus s. Okay, so let's copy this. And I'll be calling this command for my shell script, so I need to put some backslash. Supposed to be this is in one line, but okay. And we're gonna referencing the project root through the dot dot since we are in the build location. So we can delete the hyphen s as we are already pointing to that through the dot dot. And since we are already switching to the build folder, we can remove the minus b. Okay. There. So let's try to call the script now. Right, so our build script is generated and let us now start to do the build. You can type make here, but in some systems, such as in Windows, the make command may not be available. So that's why I always use the cmake build dot because the make command can be invoked inside cmake in this manner. So let me do that now. Okay, so we have built everything, and just to check, we can get the architecture type of this compiled object file. So we can see that it is an x86-64. So it is built for this machine, for my desktop here. And let's see. And then we can do the install. So either we can also make install, or we can do disable dot, then target install. And here we encounter our first error. We need to be able to understand this cmake error. So it says here that we cannot write to the root folder c /. So if we look at the build script here, so it seems that this variable is empty because it is not there's no prefix here. Usually in these kinds of errors, the first thing that I thought was other versions of cmake the may have missing cmake variables. Mm, But in this case, the cmake current source there is so basic into the fundamental operation of cmake. It is therefore present in all versions of cmake, including the very old versions. However, other newer variables that are only defined in the newer version of cmake may not be present in older versions of cmake. So take note of that. But in this case here, This variable is only going to have a value when it is invoked as part of a chain from a main cmake. However, notice that we define it in a shell script, and in fact, if we echo the value of that here, you'll see that it's actually empty. Okay, it's empty, and that explains why this we cannot write into this row of location here. Again, this cmake variable will only have a value, and it's going to expand to a valid value if it is invoked within cmake, not from a shell script. And the value of that is gonna be this path here. The cmake current source there is going to be this highlighted path here, where the cmake list is located. Okay, so we're gonna adjust the build script, and we're gonna delete this since it does not expand to a value. And since we are now in the build folder, so we're gonna delete here, and it understands relative directory. So install there is whatever is is the install there on top of the current directory. So since we are in the build location here, so install there is going to be here. Okay. Usually when I change the cmake, just to be careful and to be at the safe side, I delete everything and then I run cmake again. There. And then I'm running the cmake build, and everything should be built now, and then cmake build target install, or you can just type make install, the same. And now we have successful installation, and you can see that the install there is here on top of our current directory, which is here. And if we're going to examine the insides of that, we see that it has the bin include lib. In the bin, you can see the MQTT executable, and the type of that binary executable is an x86 64. We can therefore run that here, and it's correctly executing. Of course, we need to try to set the path of the library accordingly, but it is executing as seen from the output here. Now, how do we cross-compile this to an ARM64? Now, let me delete all of this. Now, let me go back to the, okay, because in the cmake script here, we don't see any hints of intention or possibility of cross-compilation. In fact, in the cmake list, let us try to search for ARM, ARCs, or okay, and there's no such thing. Even GCC, see. Okay, there's no such definition of those variables. So what's happening here is it's taking in the default value of the compiler in my system, which is GCC. So, okay. Now, in order to cross-compile this, we need to override a well-known variable, the CC variable. Right now, that variable has no definition, but it is a well-known variable that is used during standard builds of a Linux. So in my system here, I have a cross compiler, arch64 Linux GCC. and it is located here, and that cross compiler is for ARM. And we're going to use this cross compiler, but in order for this to be picked up in the build and building the MQTT, cross compiling the MQTT, we're going to have to define the CC variable and specify, tell it the path of the the C cross compiler. So take note that here our target board is an ARC64, and therefore we have the cross compiler ARC64 here defined in the CC variable. And now that that is defined, we'll have to redo all of the steps that we did before. sh run the build there, and then um, make or cmake builds the same. Now that the build is successful, let us try to interrogate again the object file, the file type of this binary object file. And we can see this time that it's an ARM64. And if we're going to do make install, and then we're going to see an install there, bin, and the generated executable this time would be on ARM64. So if we copy this generated executable over into the ARM64 board by SSH here in the MP location, and we source back here, and we can see the binary copied here. And if I try to execute this in the, and it's executed properly. Of course, it's looking for the needed dynamically linked library. Take note that if we, it still has our memory of its dynamic linkage with the library here. So whereas we are now in the ARM64 board, the build binary has is looking for the library in this location, same as in our build machine here. Well, that is just accidental in this case. We can fix that later on. So now we have successfully do cross-compiled using cmake, and how we can do that very easily by defining the cc environment variable and never even modifying a thing of the existing cmake build script. That's it for this demo, and I hope you pick up some uh, tips in terms of the basics of cross compilation and basics of cmake, and how to overcome some common errors in cmake build script. Thank you.